Good morning, Alyssa. Good morning. Thank you. Good morning, Charlie. Good morning, Jayla. Thank you. And yes, and good morning, Daniela. And good morning, emoticons and emojis around and across the universe. Oh, I'm sorry. I totally missed. No, I didn't. Good morning, Noel. Good morning, Daniela. Or did I say Daniela? I'm sorry. Good morning, Vivian. So good morning, Alyssa. Good morning, Charlie. Good morning, Jayla. Good morning, Noel. Good morning, Daniela. Good morning, Vivian. Okay. Good morning, Julian. I'm sorry if I didn't. And did I say Alyssa was the first? Okay. Okay. Clearly, I'm. All right. We are going to. Who just came? Someone just came. Sorry. You know, if they just had, oh, it's Farouk. Okay. You know, there was a time in my life, and I hope it's not as true any longer, but there was certainly a time in my life, and it was called like 99% of it, where if they could just take those two words and combine them into one, if they could just combine the words thank you and I'm sorry into one word, like maybe like a lisp apology, like sorry, like that's pretty much all I ever had to say or ever felt I ever needed to say. I had no content other than sorry and thank you for like everyone at all times. I still feel the power of thank you, but I feel like sorry is a little bit like of a wasted emotion. Not that I don't feel it all the time. Okay, so I'm just letting, okay, I'm sorry right now that I'm stalling. I'm not stalling for any reason. I'm just letting people in. I think we want to get back. I know we want to get back to the practice exam. So again, I need to put into Google Classroom, but let me, good morning, Sawad. Good to see you, in effect. Well, good to symbolically see you. And good morning, Farouk. Good to see you. Yes. Okay, nobody has missed anything except for my little moment of self-administered therapy, which is all that teaching really is. Oh, I heard this weird quote over the week. Right, so I'm just, okay, no, I'm trying to get us set here. Let me tell you the agenda for today. Mathematically, perhaps the agenda is on the screen there, but the real agenda is, let me remind you again, like we have class today. We have class this Wednesday, unless you know something I don't, by the way, which often is true. If there's any reason we don't have class this Wednesday, please tell me in the chat or something, but I think we do have class this Wednesday. And also tell me in the chat, if someone could tell me in the chat, remind me, please, in terms of your lab, can you just remind me? I'm pretty sure that with this group, I'm pretty sure with you guys, could you just remind me in the chat when you have your lab period? I feel like it's Thursday, but I get the two groups confused. It is Thursday. Okay, thank you. Great. And thank you for being so fast. That's totally points. That totally makes me happy. Thank you. So it is Thursday. Okay, and it's with and in this group, it's with Professor Wu or it's Professor H. Walters. I get confused. It's Walters. Okay. And it's Thursday. Okay, great. All right, so I know where you are. Okay, so then it's the other group there is a group that has lab on Wednesday evenings, and I can never remember which it's. And when that lab is over is when your exam will be posted. I have to get back to you on that exact details, but so it's either going to be posted. It's around 8 p.m. or so Wednesday night. Your exam will be posted in Google Classroom, like it'll be called an exam and all that, but it'll be under that whole section of Google Classroom called assignments. It'll in every way, it'll feel like or look like just a big homework assignment. Only it's worth 100 points. What was I going to say? And it'll be due back right before class the following Monday. So it'll be again, I'll write this out in Google Classroom. Maybe I'll even write it out right in the middle of this class so it's official. But just to remind you, Wednesday, November 10th, that's this week, at somewhere around 8:30 p.m. You'll be notified in the normal manner. Your exam will appear in Google Classroom. You will have until Monday at 10:49 a.m. to return it back to me. Let me not dwell on that, but let me try to be clear on that. In those intervening days, Thursday, Friday, Saturday, Sunday, early Monday morning, do whatever you want in order to acquire the understanding and knowledge necessary to do this exam. That is, again, you can go on the web, you can talk to your friends. I hope you do, in fact, particularly your friends in this class. You can talk to experts. You can look at textbooks. You certainly can look at your notes, which I really do hope you do. You can do whatever and you certainly can go back and forth to the document it's like a big homework assignment in that sense. Okay, let me just repeat. And I don't want to spend all period saying this again, but especially in case there's questions or anything, you can ask me during this period or next Wednesday. You can do whatever you want in order to acquire the understanding necessary to do that exam. Then at the end of the day, you sit down and I encourage you to do drafts. I really do encourage you to do a drafts, but then by Monday morning on blank sheets of paper, you will have written out full solutions to whatever questions are required by the exam, like to all the questions that you have to do for the exam. You'll have written out full solutions. You'll, in those solutions, make clear at any moment what question you're answering and what the question is. You will produce a document that requires me to look at nothing but the document in order to read it and follow it and assess it. You might, even if you want to be extra careful, if you want to be extra thorough, while you're answering all the questions and answering them as thoroughly as possible with diagrams and with making the question clear and with showing all your work and with general definitions and principles and stuff. If you want to, if it helps you, you can even label as you go, like this is step 1 of the problem solving process that we do in this class of the 5-step method. This is step 2. You don't have to do that, but you can if it makes it more clear to you. You want to do anything you can to make the whole thing as clear as possible to me. You can put the point values next to while you're, you could say this is question 1. Part A, it's worth 20 points. I'll tell you the point values in the exam, but you can tell that back to me if you think it might help it make it even clearer and faster for me to grade the thing. You're making whatever decisions you want to, you're trying to convince me. Your exam is convince me that you really understand this material. Okay, that's what you're doing. You're not convincing me of the right answers. I know the right answers. You're not convincing me that you have the right answers. I would hope that you would by that point. Today, when I stop talking about this, I'll give you more right answers. You're convincing me in your exam that you understand why the right answers are the right answers. You're doing anything and everything that works with your personality to do that. Some people use lots of different colors. Some people make more pictures. Other people make less pictures. Some people are more mathematical. Some people are more English. If English is not your first language, by the way, you can also include things in your first language. I'm not even kidding. Like, I don't assume that I speak all languages, right? But if it helps clarify things for you to have little notes in there in your own person, in your native language, but then put translations next to it, Godspeed. Don't make it look like you just copied that from Chegg or something, but you know what I'm saying? Be as personally expressive as you can to show that all this physics has gone from the universe into your mind, filtered through your personal mind, and come out of your pencil onto your paper by 10:49 and 39 seconds, 59 seconds a.m. Monday. Let me quickly say something about that, and then I'm going to go on. We're going to deal with material of it now. Again, you don't have to quote where you got things. It's not about APA research. I know that you will have done research and you will have gotten things from friends, or that's okay. None of us made up this physics. I didn't make up the physics. So it's not about quoting where you got things, but it is about only writing them down by the time you actually understand them. I hope you follow that at this point. And I hope you trust, if there's one thing that I can tell the difference, I can tell the difference between whether someone understands what they're writing and when they don't. Just, if nothing else, think of this as though you were in a language class and you were having to write, like say we're taking French or something, and you had to write in French an essay about what you did this summer vacation, right? You know that we would know, the French teacher would know the difference whether you really wrote the essay or not, right? It's like that, okay? But anyway, I think you get it. One thing, it's hard to predict what I'm loose about and what I'm tight about. I think that's often because I'm very loose about a lot of things, but I'm actually very not about certain others. So the one thing I'm going to warn everybody, this is super important. Again, you can do use whatever resources you want in order to finish this exam and get it in on time by 10:50 Monday morning. And you can still be super late on homeworks. I'm late with some of your homeworks. You can still, as long as the homework portal still exists, you're still time to hand in homeworks. And I wouldn't even worry about those now. I would just worry about the exam now and go back to them later. Homeworks are one thing, but I do have to warn you all. The exam, what makes this as an exam in part is that it is an exam, meaning you do have to turn this thing in on time. Let me just say that clearly before I go any further. You do have to turn this thing in on time. And that means two things. One, it means, and we can still talk about this Wednesday. I mean, Wednesday, all class period, I'll still be answering questions about the practice exam in order to prepare you for the actual thing. But come Monday, a week from today, the exam does have to be turned back to me through Google Classroom right before class. It could be right up to that minute, but it has to be right before class. Like, this is one case where the digital feature of Google Classroom, where it stamps whether the thing is on time or not, I will take that seriously, and so will you. You don't want Google Classroom to stamp this thing late, and you need to show up to class Monday. Like, Monday will breathe. It won't be a hard class. You'll have turned it in, but your responsibility to this exam continues through that class period. Like, you need to show up in that class period and be there, at least with your black box, to show your other classmates that you did the right thing. Like, because anybody who's still not in class that morning, everybody else is going to think that they're still working on their exam. And maybe they are. And everybody else in the class is going to think that they're somehow taking advantage of taking an extra 40 minutes to turn it into me, whereas everybody else killed themselves to make it in on time. And I do have to be very serious about this, especially because there will be all this looseness until that point. You don't want to be the person that looks like they have not held up their bargain to all your other classmates, especially if you guys work together during the 5 days, which I hope you do. Then you've got to show up with this thing and show up to class and be there ready to go. I mean, even if you don't show video, I'm not saying like suddenly you have to show video if you never have before or something. And I'm not saying you can't like go back and forth, go to the bathroom, like whatever you do, but your black box, your name has to be there so that your colleagues know that your thing is turned in and you're now done and you're not cutting extra corners that they didn't get to cut. Okay. The serious thing that I am serious about, because I let a lot of things happen that a lot of other people think are cheating. I don't think they're cheating as long as everybody's allowed to do them. But I do think it's cheating if someone does something that no one else is allowed to do. And that's one thing I can enforce, is that your exam means you turn it in by 10:50 and then you sit in class, like at least for the first 15 minutes, and like show everybody that you're there. Okay. And then if you have to fade because you just can't take it anymore, then you fade. But at least everybody knows you've turned in your exam and you're here sweating it out like everybody else. Okay. That's the one. And so what do I really mean by that? Since we've never had this experience before, this is our first physics exam together. We're going to have a final also. Hopefully you'll all be with me in physics 204 to go through the same routines, and they will be the same routines, same type of exams. Okay. So I don't want anybody to freak out in advance. It's very hard to screw up your whole grade permanently just from this one exam. Let me tell you that right now. Like, if you put a good faith effort and you do it right, and you don't cheat and you turn it in on time, even if you don't do as well as you're hoping or wanting, it will not, I'll tell you in advance right now, even if you don't do as well as you're hoping, that doesn't mean your chances of passing the class are over. And passing the class is defined differently to different people. Okay. Is it possible to blow an A by your exam score on this exam? It's possible. It's possible to write yourself out of an A, but it's not as likely as you think, and it's not as frequently the case. Like, people can bomb this exam and still, through lab and through the final and through other things, still get at least like an A-. Really. So I don't want you to freak out, but I do want you to understand that this exam is our first experience doing this together. And so I want you to be as unsurprised as possible. Where I will be strict is the on-time aspect of it. So what does that really mean to you? Like, what are the consequences if you're not? What it really means is this, two things. One, if the thing really does come in late and there's been no discussion of it, you didn't notify me in advance. If I'm just literally suddenly I see your exam is late, or I don't see your exam at all that day or something, we are going to talk. And I am going to like look at you. What exactly happened here? Like, where did you miss? Were you not in the class? Did you not watch the YouTube when I said it has to be on time? Like, this is serious. Like, it almost borders on cheating in my mind if the exam is not on time, because it's like the one thing I'm saying to be strict about that's fair to everybody. So if your exam is not on time, it does not mean you automatically fail the class or you automatically go to court or something like that. But it does at the very least mean, like, after we have some uncomfortable discussions about it, it does at the very least mean that there will be score implications on the exam. Like, you won't be able to get, I won't give you all, you won't get all the credit that you might otherwise deserve if it's not on time. I do have to tell you that in advance. Like, in other words, it won't be thrown away. Nothing is like, it's not there's no guillotines here. It won't be thrown away, but there will be point reduction of somewhat significant nature. The flip side of that to everybody, and I hate to dwell on this, but again, just so that you know where I'm strict and where I'm not, or whatever, the flip side is you've got 5 days to do this exam. Like, it'll be posted, again, for anybody who just tuned in, it'll be posted this Wednesday evening. You'll know in advance before it's posted. You'll have Thursday, Friday, Saturday, Sunday, and early Monday morning to do it however you want. So the flip side is, as that time is progressing, if you start finding out that you have circumstances in your life that are unusual, I'm open to that possibility. I mean, it could be a family thing, could be a COVID thing, could be emotional thing. Things can happen. I get that. I totally get that. And they do to me. So what I'm insisting, requesting, offering, saying is that if something is going to start happening to threaten the on-timeness of your exam, communicate with me. That's the flip side of all this is, if you just start updating me during the weekend, even after the exam is out, if you ideally send me a text, and that would be ideal because it'd be the fastest. I'll put my number in the chat again in 1 second. If you send me a polite and short text, like, I'm so sorry, my relative is in the hospital, or this thing has come up, or whatever, I'm having a psychological issue and it's personal, I don't want to get into it right now. Like, just tell me something like, can I please have an extension on this exam? I think I can get it to you by Tuesday night because of mitigating circumstances. I'm telling you now, I'm asking you now, can you please be compassionate? As long as you communicate with me before 10:50 Monday morning, I will totally listen. And you don't have to spill your life story, as long as you just, put yourself on the mercy of the court. Before Monday morning, if you show me that you're seeing what's happening before it happens and you communicate with me, we can work out a deal, and we will. I'll tell you right now, and there will be no shame about it. So the flip side is just communicate. Your exam counts as on time as long as communication has come in on time to let me know what's going on. Okay. And that's serious to everybody. So I will because I do believe in individual circumstances. And if it's you this time, then it'll be someone else on the next exam, or vice versa. Everybody does have life that goes on, but you just have to be enough on top of your life and show enough of a prioritization, right? You have to show that this exam is enough of a priority to you that you can take 2 minutes to text me and alert me and confront me that this is going on. And I will, I'm telling you right now, I will accommodate. You don't have to prove anything to me. You just have to alert me, and do it in a polite, respectful way prior to Monday. And the earlier you alert me, the more generous deal we can work out. In fact, I'm going to stop right now. Can I just get confirmation in the chat, like pretty much from all of you, that you understand what I'm saying is the exam must come in before 10:50, and you must show up to class 10:50 next Monday, unless you communicate in advance. That's a yes. Thank you. Okay, I'm actually going to be personal about this one because I want to make sure. Okay, wait, here we go. Thank you very much, Daniela. Thank you very much, Jayla. Thank you very much, Vivian. Thank you very much, Soad. Thank you very much, Lakshmi. Thank you very much, Alyssa. Thank you very much, Charlie. Thank you. Thank you. Thank you, Farouk. Thank you, Noel. Thank you, Julian. Okay, and actually, I think that's everybody, actually. I think that's everybody. No, I really appreciate, yeah, I think that is literally every single one of you, I think. Yes. All right, cool. All right, good. All right. And I appreciate that. I will probably take a moment in the middle of this class to put this clearly in Google Classroom just so it's clear, but cool. I appreciate it. All right, now I'll tell you what's going to happen today. Now that we've spent all that time on that, what's going to happen today is that I have one of the problems in the exam I'd like to actually go over thoroughly, and then there's another one I'd like to probably go over Wednesday. So I'd like to cover like most of the hard problems with you before you even take it. And I have a plan to how to do that. But what I mean is I'd like to go over one of the big problems in the practice exam. I'd like to just keep, walking through the practice exam with you. And that's what I'm going to do in the absence of anything from you. However, sorry. So it's all about the practice exam today. Again, like just building up to the exam. But I'm here to say, while I like take out my document and get myself ready, I'm happily take any questions or queries or anything from you first about the practice exam or about the exam itself. So I'm going to pause for a second. I'm just going to open my document and you take a moment to see if there's, again, if your question is, can you go over this one? I'm either going to say, yeah, that's the one I'm actually about to go over. Cool, no problem. Or I might say, well, that's a little bit long. Can you be a little bit more specific? Because I think it'd be more beneficial if I go over this one over here. But anything you want to ask, like at worst, I'm going to say on time managed wise, I can't fully answer that question now. But okay, are you going to put? Well, that's a good question. Okay, good question. Someone in the direct chat just asked, am I going to post actual solutions or just go over? The likelihood is I'm not going to post an extra. I mean, I used to. We did used to do that. And maybe you can even find them on the web. I don't think certainly I'm not going to promise that I'm going to. Mostly whatever solutions I'm going to give you guys, I'm going to give you right in this context of back and forth in the class, so that you kind of at least have to look at the notes, the PDFs from these class or videos. So I think the honest answer, I mean, it's a very fair question. There's nothing, if I had infinite time and stuff, I might try to post solutions, but I kind of also want to force you guys to deal with no. So the real answer is the solution. I'm willing to give whatever solutions I have time to give during the context of these two last classes, but I don't think I'm going to post an extra document. I don't think so. Again, fair question, but I think the answer is no. But good question. And if that makes sense, and if he or she wants to put in the chat whether I know my answer is sort of like unfortunate, but yeah, that is my answer. Hold on, I'm pulling up the thing right now. And again, to be clear to everybody, the practice exam, which is what we're talking about here, and that is what the direct chat person was just asking about. To be clear, again, it is the best way to study. It's the way you should study. The more you know this thing inside and out, the more set you are for the actual exam. And that's the other reason I'm not like, we're sort of examining you on. I want you guys sort of to pay attention to the way I talk about it. If I just post solutions, there's a little bit of a fear that people just directly copy them, which is sort of not the point. But so, okay. But I hope everybody is, I think it is clear to everybody, you're not being asked to turn in this practice. It's just for your sake. Okay. So I'm looking back. Okay. I'm looking I don't know. And if that direct chat person, I know that's an unfortunate answer, but if the direct chat person could just tell me in direct chat whether at least my answer was clear or not, even if it was unfortunate, I just want to make sure it was, but any other questions again, or I'll tell you right now, I mean, and partly I'm just being realistic too. I'm just a little worried that if I promise that I'm going to post them and then I don't get to it, then everybody's going to rely on them. So I don't want you to assume that they're coming. There might be more solutions that get posted, but is that clear, direct chat person? Or are you so mad that you don't even want to? Now I'm afraid that I've let everybody down. Wait. One second. Okay, all right, at least okay. And that person in direct chat totally gets points for the question and for closing the conversation, just to be clear, he did or she did. But all right, any other, so I'm gonna go over more stuff from the practice exam right now. But is there any other specific questions about it that anybody wants to ask or anything? Okay, here's one thing. Okay, and you can stop me at any time if I start. And really, today and Wednesday, if any of you feels that I'm going too slow or too fast, you really should let me know. Like if you feel I'm talking too much about the wrong thing, I mean, you should drive me as best as you can. So I'm going to turn to the practice exam now and start going over some things. But I'm going to tell you too that what's on the board right here, you might is very relevant to the exam and everything we're doing. It might even look like, I don't know if it looks old or new, but here's what's on the board right here. Remember that we have, and again, I'm going to apply it in a second, but remember that we have this thing called Galileo's principle of relativity that is underlying everything we do. It seems like in some ways it can seem at this point in physics like we have a bunch of equations that we're mathematically churning through, and that's sort of like what most people want to see or seem to be the most directly helpful with the problem solving that we've got to do on these exams, is solving problems, right? But then in the other side of the room, we've got these like English statements about the nature, the character of motion, velocity, and they are the different forms or the different versions of what we call Galileo's principle of relativity. And for many of us at this point, I can certainly imagine why it seems like sort of two different threads at the same time. And it can really seem like, well, all right, we got all this. Yaverbaum is always like talking about this philosophical, like Galileo stuff. And it's sort of interesting, but it doesn't like, how does it really connect to the crap that we really have to do, which is like mathematically solve these problems, right? I mean, I can very well understand if that's sort of how you think of the two elements of this course. They come together more and more as we progress. They really are one and the same. And one way to see that is, remember, you need, the more you know Galileo's principle, the more really you can effectively solve these problems that are what the exam asks you to solve. Let me tell you that you've had 3 forms of Galileo's principle thus far. Actually, you've actually had 3.5. And you can go back and check the notes in the videos for what those forms are. And each form is just that, a different form, a different way of perhaps a more advanced or more applicable way of saying this same fundamental idea. Well, I'm going to tell you right now, the 4th form number 4, is where it starts looking much more mathematical and where it starts really looking like something that can directly translate into the mathematical stuff that you have to do on this exam. So I'm going to show you today how what's on the board right here, or on the pad right here, is going to directly help you solve at least 2 of the big problems in the exam. I'm going to show you which problems they are. In fact, I'll tell you, this is very, what's written right here is extremely applicable. It is just a mathematical way of saying Galileo's principle, a principle that I think you're getting more and more used to. This is totally crucial for solving. I'm going to flip through. I don't want to switch boards yet, but it's actually, okay, in some ways it's crucial for every problem, but specifically if you go to your exam, your practice exam, and you look at part 2, Galileo's principle of relativity, 20 points without a paddle. I'm going to talk about that today, but that problem it's sort of like one of our early homework problems. It's super simple, but it's not easy. Like once you see it, then you see it, and it's not a lot of math at all, and it just all like falls into place. But if you don't see the concept, then you can do all of this math and get yourself caught up all in a twist and still not really see the answer. And I'm telling you right now, and I will tell you specifically how, that problem, again, I guess I could scroll in a second, but that problem on the practice exam, and I hope you have yours out in front of you, part 2, Galileo's principle of relativity, 20 points, subtitled without a paddle. If you really get what I have written here on the board, you'll be able to solve that very straightforwardly. But then even more specifically, and we're going to get to this, if you go to the practice exam, part 4, 2 dimensions, certainly problem 1, the Yaver-Bomber, can be solved, but that's even more a little bit with to be honest, the problem one Yavor bomber is very much like the problem we just did together last Wednesday. But problem 2, free float, which in some ways might be the most sophisticated problem of the whole exam. In some ways, just because of the order in which we do material, problem 2, the last page, page 9 of 9, which is called free float, I'm going to try to analyze today. I don't know if I'm going to finish the whole thing, but that one maybe is the most advanced in the whole exam. That one 100% solvable with any of your equations thus far, but plus what's written on the board right here and now. So before I totally open the exam, let me quickly tell you what I mean by what's on the board right now. And I do mean sort of quickly. And maybe you, so, okay. Picture any 3 objects in your mind, any arbitrary, I'll write it, this arbitrary 3 objects. Okay, if you have 3 objects, A, B, and C, and they're just like random objects, but each one of them has a distinct, I should say, constant, each one of them has a distinct constant velocity. And remember, velocity is speed and direction. So you have 3 random objects, one's going like this at a constant speed and direction, one's going like this, constant speed and direction, one's going like this, okay? What we're saying, the nature of velocity, remember, the laws of physics are the same at all constant velocities. That's Galileo's principle. We just keep saying it different ways. It just keeps having different, more and more sophisticated implications. Here's mathematical implications of that. What we're saying is, number 1, VAA, triple equal sign 0. What that's saying in English is the concept of velocity is meaningless if you apply it to only one object at a time. Any object, A, any object you picture, if you just ask, what's its velocity? In and of itself, by itself, like relative to itself, like not what's the velocity of Earth relative to the sun, not what's the velocity of the sun relative to the Earth, just or not what's the velocity of the Earth relative to an airplane, not what's the velocity of the Earth relative to a star, not what's the velocity of an Earth relative to me, just what's the velocity of Earth. And then I'm like, just the velocity of Earth? Well, yeah, just like relative to itself, what's the velocity? The answer is always 0. That's what the top line says here. If you try to apply velocity to just one object, you're going to get 0 every time. Nothing is ever moving compared to itself, right? Almost obvious in a way, but only if it is obvious to you, that means you're beginning to get the principle of relativity, which is saying velocity is always a relation between 2 objects. So then you go to the next step, say, okay, all right, I get it now. If I want to apply velocity, I need at least 2 objects. I need object A and object B. Then I can start applying velocities. Velocity of A relative to B is what the second one says. That'll be something. It won't necessarily be 0, like the velocity of the Earth relative to the sun. Well, that's not always 0. I mean, in fact, it's like 65,000 miles an hour to the west, let's say. But what it is necessarily is the opposite. Like, see, there's a negative sign before VBA. What the velocity of A relative to B always necessarily is the opposite of the velocity of B relative to A. If the Earth is going to the west past the sun at 65,000 miles an hour, then the sun is going past the Earth to the east at 65,000 miles an hour, necessarily. Velocity, in other words, is a relation, and it is necessarily a symmetric relation. Whenever we write, so from here on in, when we think of velocities, we always think of velocities with 2 subscripts, a first one and a second one. You could say, I'm not going to make these notes. Well, yes, I am. Like, I'm saying this first object is what you might always want to refer to or think of in your mind as like the target object, or the object whose velocity you're talking about. And the second object is the reference object, or the reference frame, if you like. One object has a velocity only in reference to a second. And the order in which we write them actually matters. If I say the velocity of the Earth relative to the sun, what I really mean is picture the sun as stationary, Picture the sun as the basis for comparison. Picture the sun as having a coordinate system that is locked to it. Now make measurements about the Earth from that perspective and ask what the velocity of Earth is from that perspective. That's what we mean when we say velocity of A relative to B, or velocity of Earth relative to sun. We mean assume the sun is still, ask what the velocity of Earth is. And you might then say, well, what do you mean assume the sun is still? What's the real deal? Like, I don't want to assume. Why don't I pick an object that really is still? And what we're saying here is no, it's always an assumption. There is no object that's actually still. That's what the first part is saying. There's no object that is literally still any more than any other object. All objects that have constant velocities at all could be treated as zero. That's what we're really saying here in Galileo's principle of relativity, that as long as you have a constant velocity, as long as you're not accelerating, then the laws apply to you all the same as they do to any other constant velocity. And then you can be treated as having zero velocity just as correctly or incorrectly as any other object. So VAB means pick B as still, ask what the velocity of A is. You'll get some number that's valid. And whatever that is will be the reverse of if you reversed it. Like, so if I'm on the subway going 100 miles an hour to the north relative to the streets, then the streets are going 100 miles an hour to the south relative to the subway, and both are equally correct. Both are a basis for doing physics. That's what the second part says, okay, right? So the first thing says velocities apply to one object, you always get zero. Second one says velocity apply to two objects, now you can get numbers, but they're always going to be symmetric. Always going to be symmetric. It's no mystery involved. Now the last one, and this is what we're going to get into. I'm going to apply to the practice exam. I mean, just to practice with you, but in effect, it says everything you need to know right there. The third one says, okay, what if you have three objects? That's where things get interesting. What if you have three objects? Then what it's saying is, then velocities can be added. You can add velocities once you have three objects. I'm going to be very careful. I'm going to say this sort of quickly and go back to the test, but once you have three objects, velocities can be added to get meaningful results. And they add in the exact same way that vectors add. Notice I'm putting arrows above the V's in all of these little equations here on the sheet. I'm putting arrows above the V's to really explicitly signify that I'm not just talking about speeds here. I'm talking about velocities. I'm talking about quantities with magnitude and direction. And I'm really talking about vectors now, magnitudes and directions, vectors kind of in the way that you did in lab 3. And I know you just maybe recently, or you're about to start lab 4, and I started talking about in class. I'm talking about vectors, quantities with magnitudes and directions, even taking into account more than one dimension at a time, 2 dimensions like a plane, or maybe even 3 dimensions like actual space. I'm saying we did one exercise together, I know, as a group, and I posted the video. If you haven't, we did one, I don't remember if it was this group or the other group, but we've done one exercise, and it was posted, where I took a couple of displacement vectors that were in 2 dimensions, and I added them. It was this. It doesn't matter. Definitely check out the videotape if you don't. There's one YouTube called Adding 2D Displacement Vectors. I highly recommend that you do check that out. It'll really help you a lot for the very last problem of this exam. Let me say that again. If you check out the video, adding 2D displacement vectors, or addition of 2D displacement vectors. Yes, I think it was the other class that I actually did it, that I posted the video. So please do check it out. It will actually, whether you see it or not immediately, it'll show you how to do the very last problem of this practice exam. I mean, even though I'm going to go back to that in a minute. And what it shows you in that video is if you're adding 2 displacements that are in different directions, that are actually like not only have east-west aspects to them, but also north-south aspects to them, as you were in effect doing or are doing in lab 3, right? It shows you how to add these vectors together and get one final vector. It shows you the principle that when you're doing addition in 2 dimensions, that's really like equivalent to doing 2 addition problems, each in 1 dimension. Let me say that again. It's showing you how doing A, two-dimensional problem in physics is really the same thing as doing two one-dimensional problems simultaneously yet independently. There's a whole video about that, and it does it in the example of displacement vectors. And that's what your lab 3 is really about, adding displacement vectors in higher dimensions. I'm here to say that that applies to velocity as well. I'm going to try to apply that to the very last problem of this practice exam. Again, I'm going to get to it in a couple of minutes in this class. Even if I don't finish it here, I'll finish it Wednesday. Again, let me say, I think that's the hardest problem in the exam. So if I can do at least the hard part of it for you, I think, and you can follow it, then I think you'll be in good shape. What I'm saying right here and now is, that problem entails that you understand that velocity is a vector, and it works just like displacement vectors, even in higher dimensions, even in 2 dimensions, that velocity vectors add and get other velocity vectors as long as we add them component by component, as long as we add up all the velocities that are happening in one axis independently, and we add up all the velocities that are happening in the other axis independently, and then we put our results together so that they occurred simultaneously, then we've added velocity vectors. What does it mean to add velocity vectors? Like what does it mean? I mean, if you add displacement vectors, I think we all sort of understand you're accumulating displacement space. So like if I walk this way and then I walk that way, to add those 2 vectors together is to really ask, well, how far and in what direction did I end up, right? If I add this displacement vector to that displacement vector, I'm really asking, if I started here and walk like that, how far away did I end up and in what direction from there? What does it mean to add velocity vectors? It means this, and I'm going to turn the page and go back to the example. If you look at the third statement, VAC equals VAB plus VBC, what that really means is adding velocity vectors, adding velocities is meaningful and possible as long as we carefully account for the relational character of velocity, meaning that we take into account different frames of reference in an appropriate way, meaning this: let A, B, and C stand for any 3 distinct objects, like on the board, like A, B, and C are 3. Say, for example, A stands for me, B stands for the subway, and C stands for the streets, New York City streets, let's say, okay? What we actually all know, that we actually all believe, look at the notation, like with me, like if A stands for me, if B stands for the subway, and C stands for the streets, then what that third statement there, that third form, well, that third line of the fourth form of Galileo's principle of relativity, what it's really saying is, oh, the velocity of me relative to New York City streets is the velocity of me relative to the subway plus the velocity of the subway relative to New York City streets. That's why I take the subway, right? Like every great revelation in physics, once you actually get it, it sounds almost obvious. It is almost obvious. What's not obvious is how useful it is. But if you think you know what I'm saying, if right now you're like, that's all he's saying, like, duh, then you get it. But let me say it again, because what you might not get is how universally productive this observation is. I'm saying, say I am going 0 relative to a subway, meaning I'm just sitting there in the seat on the subway. I'm not moving around relative to the subway. So let's say the velocity of A relative to B is 0. Let's say the velocity of B relative to C, let's say the velocity of the subway relative to the streets is 80 miles an hour or something, right? To the downtown, to the south. Then you put me in the subway and I'm sitting there chilling, or perhaps making a hip hop album, apparently. But no, if I'm just sitting there, and I say that with all due respect to albums, some of my best friends have albums. Okay, so I'm just sitting there going 0 relative to the subway, and the subway is going 85 miles an hour southbound relative to the streets, then add those 2 vectors together, and 0 plus 85 equals 85. I am thereby going 85 miles an hour southbound relative to New York City streets. So I get home without having to do anything, right? I mean, it's just saying velocities add, but velocities add like that. It's not like, let me put it a different way. If I'm going like, well, let me take it one step. Well, what it's saying though is you have to be careful about the frames of reference. Like they add almost like in a transitive manner like that. Like for example, if I throw a baseball in the subway, if I just throw a baseball and you throw a pen in some other, it's like, so I throw a baseball going 45 miles an hour south relative to the subway, and you throw a pen going 20 miles an hour south relative to the subway. So you got this baseball and got this pen. They each have a speed, 45, 20. You could add the numbers together, 45 plus 20 equals 65, but that doesn't mean anything. The velocity of the baseball relative to the subway plus velocity of some pen relative to the subway, you could add the numbers, but you don't get anything, but the number that you get won't mean anything in the physical world. Like it doesn't mean anything to add the velocity of my baseball to the velocity of a pen. There's just two random objects doing their own thing, both in a subway, they both have their own velocities. Who cares if we add the numbers together? Right? So it's saying you got to be careful about comparisons in velocity. If I start walking on the subway, and you know this, right? Or better yet, if I throw something off the subway, if I throw a baseball at 45 miles an hour southbound relative to the subway, and the subway is going 85 miles an hour southbound relative to New York City streets, relative to the platform, relative to people that are standing on the platform or watching the subway, or standing on the street looking down, watching the subway, right? Now, if the subway is going 85 miles an hour relative to them, and a baseball is going 45 miles an hour relative to the subway, then those can add, they do add. And then we would say that the baseball is going 130 miles an hour relative to them. And that is true, right? Like whether the baseball is off the subway or on the subway, if the baseball is going faster than the subway and the subway is going faster than them, then the baseball is going really fast compared to them on the streets. And you know that's true, right? If you ever pass people on the escalator leading to the subway, like same principle applies, right? If you're going 5 miles an hour relative to the escalator, and the escalator is going 20 miles an hour relative to Columbus Circle Station or to the mall or whatever, then you pass the people that are standing on the escalator, right? If you go faster than the escalator and the escalator goes faster than the mall, then you're going faster than the mall. And right? Like velocities add is all we're saying here. And they literally add, they add according to their frames of reference. You have to line up the frame of reference appropriately. A to B plus B to C gives you A to C. That's what it's saying. Even in the most complicated, now what's powerful about this, and then I'm going to move on, I will turn the page, but again, it's sort of obvious, like you wouldn't take subways if you didn't believe that velocity is added that way, in a way. But what you maybe only sort of sometimes think of is that addition works, first of all, even when there are minus signs, right? Like my two sons know this. I mean, one is 7 years old, the other's 18. Both of them have gone through a stage where it was totally fun to run up the down escalator, right? And perhaps you, and you know who you are, perhaps you've gone through this too, or run down the up escalator. And we all know, I mean, I think it's fun. I mean, it's only 400 years of therapy you take to get that out of me. I think it's fun. And what's fun about it is if without even doing the math, you can bodily try to arrange the math so that if the escalator is going up at like 15 miles an hour, you can like try to run, if the escalator is going up at 15 miles an hour relative to the mall, and you try to run down at 15 miles an hour relative to the escalator, then what you have is negative 15 plus positive 15 equals 0. That's your velocity relative to the mall. And you know, if you do this right, if you like get on the escalator and go in the wrong direction at the right speed, someone watching you can watch your little legs go blah, 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 like the roadrunner or the coyote or whatever, go blah, 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 and watch as your body advances nowhere through the mall at all, right? Hopefully you guys know what I'm talking about. Velocities add like this, even when negative signs are involved. And here's my final statement about what, even when things are in more than one dimension, which is the whole point. I'll say this again. now I walk you through the mechanics of it, but in way you now have everything you need to know to solve the very last problem in the whole exam, which is in the whole practice exam, which is possibly the hardest problem there. But all that's going on in that problem is you've got a bunch of different velocities in different directions within 2 dimensions. And if you really look at the wording of the problem, it's just cycling you through these 3 statements here. It's asking you, so you have like a frog going at a certain speed relative to the water, and then you have water going at a certain speed relative to the land, or something like that. And it's ultimately asking you, what's the velocity of the frog relative to the land? And I think I just said the words right. It's not a frog, it's something else, but it's like that. It's 3 objects. If you really look at the very last problem of the exam, again, I'm giving you like an overview here, just in case if you look at the very last problem of the exam, there's 3 objects, and they're given, and you're provided with their different velocities relative to different frames. Ultimately, what it's asking you is if frog has a velocity of blah relative to the water, and the water has a velocity of blah relative to the land, what's the velocity of the frog relative to the land? And it's asking you to take their different velocities that are in fact in different directions within 2 dimensions, and it's asking you to add them together according to what's written here on the board. What's saying on the board is, if you really get the relational character of velocity, you will get that it adds like a vector, which means it adds just like displacement vectors, just like in some other video we posted. And yet, to know which velocity to add to which one in order to get what, you've got to respect the subscripts. You've got to respect, what am I measuring in relation to what? Like, that's a summary of what this is saying right here. It's at least 2 big problems on the exam will be solved like this. In fact, maybe right now I will turn, because I keep alluding to it. I'll turn to that problem right now and show you what I mean. Okay. Again, this also applies, however, to the without a paddle problem, but once you really get this, that one's even more straightforward, because that one actually involves only 1 dimension. So I'm being very abstract here. I'm going to turn now. I'll quickly even share the screen, just show you what I mean. I'm going to quickly turn. Hold on. Hold on. Yeah, let me. Okay. Give me 1 second. Again, I know I'm all over the place. You can stop me. You can tell me to go to change course or go to a different problem. You can tell me to slow down or speed up or whatever, but I'll show you right now. Hold on. I'm just going to show you on the screen what I'm talking about, so it's clear, hopefully. It's coming, pardon me. Okay. And maybe if you want, it's not required, but maybe if you want, in the chat, you could privately or publicly tell me if you're just still with me, if this is making any, if I'm like doing anything that's helpful, but here you go. All right, hopefully, all right. So what okay, here's a practice exam, right? What I'm saying is, just to be clear, like, I think the first couple are the first 3 are practice. I could try to scroll out the answers really quickly, maybe in the last class if you want, but I'm sort of hoping that you kind of can share answers with each other for those and have some clue. The very next one, though, where it says part 2, Galileo's principle of relativity, it's totally what I'm talking about right now. I will warn you and I will actually try to solve it for you either today or Wednesday, but that second one, sorry, did I just lose it again? Okay, this second one is everything I just said right now, but you don't even need, it's all in 1 dimension. What you really need to take really seriously is the first, is those 3 statements I just had on the board, but you don't even have to extend them into 2 dimensions. It's all 1 dimension. I'll even give you a big hint about it right now, if you're still with me, just to reward people who are paying attention. With this question, without a paddle that you're looking at the screen right now, it's really testing how much you believe that the laws of physics are the same in all reference frames. So what I'm saying is here, if you never took a physics class, or you just took a high school physics class or something, the common way to try to solve this problem, the common way is to take all those numbers and stand on the shore and think about all those numbers that are given from the perspective of someone standing on the shore, and to try to do physics from the perspective of someone standing on the shore. And that can be done, but it gets very hard to actually answer the question from thinking about it from the perspective of the shore. But if you take Galileo really seriously, and if you attempt to solve this problem from the perspective of the bottle, that is to say, think about how adjust those numbers, or think about what those numbers mean, or what's being said. If you were the bottle watching, if you were just a bottle in the water, so you're the water going along and you're watching the shoreline move up past you, and you're watching the boat move up away from you, you're watching the bridge move up away from you. If you think about the problem from that perspective and you run the numbers from that perspective, you'd be amazed how much simpler the problem is. And if you really believe Galileo, you'll realize that that's just a valid way to do physics, as doing it from the perspective of the shore. The shore isn't any more of a correct frame of reference than the bottle is. So one big hint for that problem is try to solve it from the perspective of the bottle. And if you do, and if you follow what I'm saying, you'll get an answer fairly straightforwardly. Maybe I'll even tell you, should I even tell you the answer? I'll even tell you. Hold on. Hold on, I'll even tell you. For this problem without a paddle, I'm not going to work it out right now, but I will tell you. Yeah, it's 1 mile. The answer to this problem is 1.5 miles per hour. That's not a solution, that's an answer. But if you want to see whether you're doing it right or wrong, again, I'm here. I'm without a paddle. I'm telling you the big hint. The big hint is do it. Try to solve things. Look at the facts from the perspective, from the frame of reference of the bottle. And if you do things correctly, you'll find out that the speed of the current, which is what you're trying to solve here, you're trying to find out how fast does that water go past the shore. The answer is 3/2, or in other words, 1.5 miles per hour. That is the answer to that question. Maybe in the chat, you might want to put if you just even heard that. So you have to still figure it out, but you'll know you've done it right if you get the answer 1.5 miles per hour. And I'm telling you, it's all about just what I just put on the board, Galileo's principle. But now and maybe you put, okay, someone put in the chat, thank God. Great, thank you, Alyssa, totally appreciate it. All right, cool. So now what I'm going to do, and I know I only have 15 minutes, but I actually think it will be enough. I'm going to go to, again, what I think is the hard. All of these things look really hard. They do, or at least to me, they look really hard. But if you break them down and go step by step and trust them, and trust that they're all based on what we've done in the class, they seem really hard at first, and then you get them, and then you're like, this is so easy, I don't even know what I just did. It just always feels that way in physics. You're not doing anything wrong if it feels that way. But here, all right, I'm going to go over this one, free flow. A boat travels down a river. Okay, relative to the water, the boat moves at constant speed of 12 meters per second in a direction of 30 degrees southeast. Okay, I'm going to switch boards in a second, but I'm reading out loud. What I would do right now, if I were you, in the exam, I would start diagramming this, right? I would write it, I would draw an arrow, a vector that is like 12 units long, roughly, and points southeast 30 degrees. Well, I'll draw it in a second, but that means 30 degrees south of east. And then I would draw, and that is what the boat is. All right, I'm going to do it right now. Hold on. And then it says relative to the riverbank, the boat moves at constant speed of 10 meters per second in a direction of 45 degrees northwest. That's a different vector. I would draw that separately. And then I start looking at the questions. Okay, so I'm going to do that. Hold on, let me just switch. This is a little hard. Okay. Oh, sorry, not that. sorry, I mean part. Okay, so here's the situation, right? Hopefully you can see my board. Now, that's just like the situation. That's sort of the facts given by the problem. So you might say, that's what I've just done here is kind of step one, diagram and fact pattern. I haven't even asked the question, right? And I also haven't provided those are the facts of the problem. Now I'm going to go to the next page and I'm going to say, before I even go any further, I'm going to diagram this a little bit more for my own sake, like as a student right now, or as a problem solver. I'm going to say, okay, I have okay. Notice now I still haven't even asked a question yet, but what I'm doing right now is possibly the most important thing of all. I'm setting up my coordinate system, my frames of reference and all of that. First of all, on the lower right, and this is me being a student now, right? I mean, this is me, what I'm providing to solve this exam. And you would do it in your own order, you do it in your own way. But even before I'm getting into the question, I've got like a little compass in the bottom right that's showing, okay, from here on, anything that's pointing up the page is north, and anything down the page is south, or down the rivers south, up the rivers north. And I'm literally saying anything that can point north, I'm going to call positive. Anything that's pointing south, I'm going to call negative. Then independently, but at the same time, I've got east-west axis also going on, right? It's like two physics worlds that each have their own equations or their own laws, but happening at the same time. So east and west also is designated positive and negative. And I'm just making that clear as best as I can in that little compass down there. Then I'm also, and again, I'm maybe going in a funny order here, but I'm saying from here on in, R stands for riverbank, B stands for boat, W stands for water. And now I'm drawing these little vectors, these arrows, with tips and tails that indicate velocities as they were given to me. What was given to me is that the velocity of the boat relative to the water, like I was just told this, right, in the given, relative to the water, the boat is going 12 meters per second in the direction of 30 degrees southeast. Notice how I make an arrow representing that. That arrow right there is just an arrow that represents the instantaneous but constant velocity of the boat relative to the water. Please understand, like, it's pointing at 30 degrees south of east. It doesn't mean 30 degrees compared to anything else. It means if I think of east as directly to the right on my page, then this thing is going 30 degrees south of that, like at all times. That is what I would observe and what I would measure if I were standing in the water, or I shouldn't say standing, if I were a lily pad in the water. If I were the water looking at the boat, measuring the boat, if I were the water viewing myself as at rest, if I view the water as stationary and look at the boat, that's what I would see the boat doing. Now, again, you might say at this stage of the game, you might say, but why? Wait a minute, but the boat, are you saying the water's actually at rest? Isn't the river bank actually at rest? What I'm saying as a physicist is the river bank is attached to Earth, which is not actually at rest. The Earth is going past the sun at 65,000 miles an hour, not a technicality. I'm saying everything in the universe is moving relative to something. Nothing is still except relative to itself. Everything is a comparison. We've got to, and every comparison is valid as long as it's a constant comparison. So we always have to choose what comparison we're making at any given context when it comes to velocity. And when you choose that context, it's like when you choose a frame of reference, it's like declaring it by hypothesis as stationary. So the velocity of the boat relative to the water is going 12 meters per second, to the southeast. I'm just flipping back screen here. Okay. Meanwhile, or another way to look at things is if I stood at the river bank and watched what the boat is doing, I would see that it's going 10 meters per second at 45 degrees north of west. Or did I write that down? Was it northwest? Was that correct? Yeah, 45 degrees north of west. Now, again, that's two different ways of looking at the boat. The first arrow is looking at the boat from the water's perspective. The other is looking at it from the riverbank's perspective. They're both equally true. It looks a little intimidating because it's in two dimensions, but it's just like saying if someone's sitting in a subway, from the perspective of the subway, they're going 0. From the perspective of the platform, they're going 100 miles an hour. That's what we're saying, right? So, but if I ever said that to you, if I said, someone in the subway is going 0 relative to the subway, but they're going 85 miles an hour relative to the platform, you would say, well, then I guess the subway must be doing something. And I'd say, right. And in that simple case, it'd be pretty easy to figure out the subway must be going 85 or whatever relative to the platform. What we're going to do here is just that. We're ultimately going to figure out what is the water doing relative to the riverbank. And even if I run out of time today, let me tell you, how am I going to do it? I'm just going to add or subtract vectors according to that thing that I wrote on the board on the first page. The thing that is so obvious and straightforward when it's applied to simple examples, I'm just going to say A to B plus B to C equals A to C. As long as I'm clear and consistent about what's A, what's B, and what's C, I should be, and as long as I'm not intimidated by the fact that I'm in two dimensions, I should be able to apply that. And that's what I'm going to do. I'm also going to quickly say, because I'm watching the clock, I know we're not going to finish this now, but I'm just setting it up for you and showing you. And again, we'll finish it and tie up loose ends on Wednesday. I really do think I'm showing you the hardest parts, though, honestly. If you believe that last, and it's always in physics, always like this. We make statements that are really obvious in obvious circumstances, and then we're just saying, yeah, but now hold on to that obviousness and trust it, even when the circumstances don't seem obvious. That's the power of the equation or the principle or the law. So here, where it says VAC equals VAB plus VBC, again, hopefully, if you're following it all, you're hopefully seeing like, okay, that just means that like people add the speed of the subway to themselves and then they get home. Yeah, that's what it means. But math still applies. So it means I could like subtract AB from both sides and say, for example, VAC minus VAB equals VAC, whatever I need to do to make it apply to the circumstances, such as these here. Like here, I'm going to end up doing some kind of subtraction or something because I've got two subscripts that are the same. Anyway, all right. Got a couple more. So the first question, we got like 3 minutes. Okay. The very first question is to flip the screen. Relative to the boat, in what direction is the water moving? All right. So here comes the first question. What it's really asking is then, relative to the boat, what's the water doing? It's asking what's VWB. That's what it's asking. What is the velocity of the water relative to the boat? Or it's saying relative to the boat, what's the water doing? And it's actually only asking for direction here. It's not even asking number. Well, how do I possibly know that? I look back and look, it says VBW equals 12 meters per second to the southeast. So look at the first page. VAB equals negative of VBA. Obvious in obvious circumstances, maybe not obvious here. What am I saying? I'm saying that if it's a given that the boat relative to the water is going 30 degrees southeast, then the water relative I'm doing this again. I'm saying here's the principle. And here's the answer. The answer is 30 degrees northwest. If B to W is 30 degrees southeast, then W to B is 30 degrees northwest. It's just that straightforward, okay? Then when it says, I'm just going to keep going because we have like 1 minute. So this is just that principle on the first page. B, relative to the boat, how fast is the bank going? Again, VRB must equal negative of VBR. It's just asking how fast here. Well, it said VBR 10, so the answer is 10. And it's just asking for the number. So it's 10 meters per second. That's the answer. Whoop, sorry. Okay. C, what? The answer is 0. You see, I'm just literally applying the principle. I'm just applying Galileo's principle rigorously to the numbers here on the first page. The velocity of the water relative to the water is always necessarily 0. So the hard part, now I'm about to run out of time. I'm aware of that. But look, the hard part here is D, what it wants to know from the perspective of the water, at what velocity is the river bank moving? That's like saying if you were standing in the water, what would you see the shore doing? Which is just the opposite of saying if you stood on the shore, how fast is the water going? It's really asking the same question that part 2 of this exam is asking. It's just asking you, can we figure out the current? If we know what the boat is doing relative to the water, and we know what the boat is doing relative to the shore, can we infer from that what the current is doing? Just like asking, what's a subway doing if you know what a person on the subway is doing, blah, blah, blah. And what we're going to do is literally, and I will not do this now, I know class is just about to end, but in order, I'll just tell you, and you can practice this at home over the next 2 days, would be a great use of your time. In D, what we're literally going to do is say, well, the velocity of the boat relative to the water plus the velocity of the water relative to the riverbank must equal the velocity of the boat relative to the riverbank, which also means we could subtract and say like the velocity of the water relative to the riverbank must equal the velocity of the boat relative to the riverbank minus the velocity of the boat relative to the water. We're literally going to subtract one of the vectors from the other that we were given at the beginning of the problem. And how do you subtract or add vectors? Watch the video on adding 2D displacement vectors. We're just going to make an XY chart and add up. Or we're just going to make an X. I'll leave it at that. We're going to get the X and Y components of each one, like we're going to do SOHCAHTOA, get the X and Y components of each velocity vector, subtract them, and get one big vector. I'm going to stop there because I know it's 12:06. That was like a lot, but hopefully that's a lot to help you work this practice exam tonight or tomorrow. Ask questions about Wednesday. I will finish this problem Wednesday. I think if you could do this, you could do anything, but just take things one step at a time and trust that they actually do all go back to fundamentals and you will prevail. And I am done. Sorry to keep you. And I'll post all this, obviously. So thank you for your attention and I'm done.